Okay, I think we are now recording. Good morning again, everyone. So today we'll continue our discussion about the basic theory of polynomial interpolation. So last time we talked about polynomial interpolation versus a generic form of approximation. We laid down the foundation why polynomial interpolation is uh, is usually used in applications because of its simplicity, its compatibility with computing machines, and also its theoretical value in the sense that polynomials give rise to polynomials as derivatives and integrals. So that's why usually favored ang polynomials in any type of approximation. And then we differentiated interpolation from approximation. We said the distinguishing characteristic of interpolation is that we require zero error in the nodes. So we proved one important theorem last time, the Unisolvents Theorem, which tells us that for any set of n+1 abscissas and n+1 corresponding data points, there will exist one and only one algebraic interpolating polynomial, which would be of degree at most n. So kung meron kang n+1 data points, sigurado tayo na may mag-exist na interpolating polynomial. And not just that, that interpolating polynomial will be unique. The proof actually convinced us that that result is true, but not just only that, the proof also provided us a way on how to construct the interpolating polynomial. So, and that's what I have here in definition 2.3, which is the Lagrange form for the algebraic interpolating polynomial. So kung meron kang given n+1 data points consisting of abscissas, the x sub i's, and function values f of x sub I, then the algebraic interpolating polynomial can be obtained by taking the summation over all data points of the corresponding y values times the Lagrange basis polynomial. And again, the Lagrange basic polynomial is just the product of x minus xi over xk minus xi as I goes from 1 to n+1 and I not equal to k. Which reminds me, I think in the proof there is a slight typo here. No, I think that's oh, wala pala. I think tama naman yung nasa slides, nasa proof, okay? Now, maybe it's a little bit tricky to devise the Lagrange basis polynomial, but essentially if you're going for L1 of x, kukunin nyo lang yung product of rational expressions, or actually not rational expressions, polynomials pa rin naman siya, pero they are fractions. They are of the form, dahil meron kang, kinukuha natin yung L1, the first Lagrange interpolating, first Lagrange basis polynomial. So ibig sabihin, hindi pwedeng magkaroon ako ng x minus x1 dito sa mga factors. So I'm gonna start with x minus x2 all over x1 minus x2. And you will see the problem right away why I cannot include the factor with numerator x minus x1. Because the pattern here is I'll just replace the x in the numerator by x sub k. So if you will insist on including x sub 1 here, okay? So ibig sabihin magkakaroon ka rito ng x minus x sub 1, which is clearly undefined. So that's why we start the product at x2 para yung denominator, yung unang denominator would be x1 minus x2. Because again, the order of the Lagrange basis polynomial is the same as the minuend in the product or in the denominator. Okay, so it will go on. You have x minus x3 over x1 minus x3 times x minus x4 over x1 minus x4 until you reach the last abscissa, x minus x sub n plus 1 all over x1 minus x sub n plus 1. Okay, and then if you're looking at the second Lagrange basis polynomial, you'll do L2. So ang bawal naman ngayon ay magkaroon ng x minus x2 dun sa product. So itong nasulat ko na x2 rito, hindi na siya pwede. Pero mag-start na ako ngayon sa x1. Though here, xk lagi yung minuend sa denominator. So this would be x1. Sorry, baliktad pala. Ito ay x2. Kasi laging yung minuend kaparehas nung subscript nung Lagrange basis polynomial. Tapos yung subtrahend, siya lamang yung manggagaling sa taas. Right? So parehas itong subtrahend sa taas at saka sa baba. Okay? So this is so this will become x2, this will become x2 until you get that. And you will do this as k goes from 1 to n plus 1. Para lahat ng Lagrange basis polynomial ay degree n. Meron ka dapat n factors. Okay? So I hope that's clearer right now. But before we proceed to the example, let's look at remark 1 here. There are other ways of constructing the interpolating polynomial. Although by the Unisolvents Theorem, lagi ka lang may makikitang isang unique algebraic interpolating polynomial after simplifying whatever you got. But the Lagrange form is not the only way to construct the algebraic interpolating polynomial. In fact, there is another method called the Newton's method or Newton's form, which makes use of divided differences. So if you are interested into looking at the Newton's form, you can consult the modules from last year. So I included here the links and the pages if you are interested into looking for another way of creating the interpolating polynomial. But I will forgo the discussion of the Newton's form kasi okay na ako sa Lagrange sa Lagrange form ng interpolating polynomial. Anyway, it doesn't matter if I use the Lagrange form or the Newton form. It is always guaranteed by the Unisolvents Theorem that I will get the same interpolating polynomial after simplification for the same set of abscissas. Okay, so it doesn't matter which one you use. There are certain scenarios nga lang wherein the Newton's form is more advisable than the Lagrange form and vice versa. So dun sa derivation ng ilang mga error terms, mas okay yung Newton's form kaysa sa Lagrange form. So kaya doon makikita natin yung possibility of using one method over the other. But theoretically, it shouldn't matter because they will give us exactly the same polynomials but in a different form. Okay. Now, let's consider some examples para makita natin paano nga ba nag-work ito. So let's start with example 2.1. I think I copied the problem here. Okay. Find the interpolating polynomial for the points 1, 1, 2, 4, and 3, 9. So here, if you look at the data set, we have a guess, all right? So kasi 1, 1, 2, 4, and 3, 9, it seems that this data set has the behavior of x squared, right? Because we are just squaring the abscissas in order to get the corresponding y values. And so if we want to get an interpolating polynomial, so we expect we'll get x squared, okay? Pero can we really do that? Well, what are our expectations? Well, yung interpolating polynomial dapat magpa-pass through dito sa tatlong points na ito. And since we have 3 points in our data set, that means we are expecting an interpolating polynomial of degree at most 2. Remember, laging 1 less than the number of data points yung maximum degree ng interpolating polynomial. All right? So here we'll get some sort of a quadratic function at most. So pwede kong i-define si P2. So si P2 of x, siya ay sum as I going from 1 to 3. Kasi ang n natin dito ay equal kay 2. So yung upper bound sa summation ay n plus 1. And then the terms in the summation are the product of the exaby, the function values of the exabytes times the Lagrange interpolating polynomial. The Lagrange basis polynomial evaluated at the variable x. So dito nanggagaling yung degree ng ating interpolating polynomial. So if we'll write this down manually, so let's do I equals 1. When I is equal to 1, the first function value is 1. So I'll put that here. So I'll have 1 times yung Lagrange basis polynomial. So I'll have x minus, hindi pwedeng ilagay ko si 1, yung unang abscissa kasi magkakaroon ng 0 sa denominator. So I'll have x minus 2 all over x1 minus xk. So that's going to be 1 minus 2. Okay. Plus hindi pa pala, times the third abscissa, x minus 3 all over 1 minus 3. Okay. Plus second function value. So I'll have 4. This is my f of x2 times L sub 2 of x, the second Lagrange basis polynomial. So it's going to be x minus 1 over 2 minus 1. Again, ito ay yung second abscissa. Siyempre, i-skip ko yung x minus 2 kasi kung ilalagay ko yung x minus 2, magkakaroon ako ng 2 minus 2 kasi dapat yung mga subtrahend ay parehas. Ibig sabihin, this cannot happen, so I'll go to the next one, to the third abscissa, which is 3. So I'll have this. And then lastly, plus, I'll have the third function value times the third Lagrange basis polynomial. So I'll have an x minus 1 all over 3 minus 1 times x minus 2 all over 3 minus 2, and then that's it. And then if you are patient enough, you can do the calculations, and this will simplify nicely to x squared, as we expected. Okay? So dahil degree at most 2. Okay? Any questions? I hope the Lagrange basis polynomial now makes better sense. Kasi parang last time, sabi nyo, yun yung nakakalito, yung pagko-compute ng Lagrange basis polynomial. So kung isipin nyo, talagang napaka-clever ng pagkakadesign ng Lagrange interpolating polynomial. Kasi pag pinlog in nyo halimbawa si x equals 1, pag pinlog in nyo yung x equals 1, ito ay magzi-0. Okay? Ito ay magzi-0. So ibig sabihin na nagmamatter lang when x is equal to 1 is the first term. Pero if x is equal to 1, this guy becomes 1, this guy becomes 1, maka-cancel siya. 1 times 1, which is the first function value. If x is equal to 2, then ito magzi-0. Ito magzi-0 din. So yung first and third terms will just be equal to 0. So the only thing that matters is the second term, right? And if we plug in x equals 2 in the second term, 2 yan, oops, cancel to 1, 4 times 1 times 1, we get the second function value. And that's how we force, or that is how we force the issue that the function values match the data set. Okay? Kaya kung isipin nyo, napaka-clever nga. Simple but clever yung pagkakadesign ng Lagrange interpolating polynomial. Okay? Any questions? I hope that makes better sense now. Okay, I'll take that as no question. So if we go on to example 2, you can do the same thing. Pero sa example 2 kasi ay may additional data point. 4,16. So yung makukuha niyong Lagrange interpolating polynomial will have 4 terms, right? 4 terms na bawat isa ay degree 3. And what we expect here to be our answer is a polynomial of degree at most 3, right? Kasi meron kang 4 na data points. So ibig sabihin, at most degree 3 yung makukuha natin na interpolating polynomial. But if you do the computations just as what we did in example 1, makikita nyo ay ito. Ito yung lalabas na interpolating polynomial. Okay? Pero pag sinimplify nyo yan, si P3 pala ay x squared lamang din. Okay? And that's there's no problem with that because what we expect is an interpolating polynomial of degree at most 3. Hindi lalampas ng 3. Pwede siyang bumaba, just as what happened in example 2. And actually, you can attribute the deficit in the degree by saying that the added data point actually adds no more information in terms of the interpolation process. Kasi alam na natin na ang pattern dito ay x squared. So, nagdagdag tayo ng isa pang point, pero parang x squared pa rin talaga yung behavior niya. So basically, ang nangyari dito, sa example 1, Meron tayong 1, 1. Meron tayong 2, 4. Meron tayong 3, 9. Somewhere there. So, nakuha natin ang nagpa-pass through sa kanya ay parabola. Degree at most 2. Pero pag nagdagdag ka pa ng 4, 16, tapos naghanap ka ng polynomial na magpa-pass through dun sa 4 na points, syempre, alam natin yung parabola, magpa-pass through pa rin sa kanya. And that is a quadratic function. It has degree no greater than 3. So yun pa rin yung makukuha natin even if I add a 4 point. And the thing I'm trying to point out here is posibleng may deficit dun sa degree, especially if medyo redundant yung additional data point. Okay? Now, what will happen if I say decrease the data points? And that's example number 3. Let's try here, example number 3. Tinanggal ko yung pangatlong data point. So I only have 1, 1, and 2, 4 as my data points. Okay? Kahit alam natin na x squared pa rin yung behavior niya, kasi 1 squared is 1, 2 squared is 4. But at this point, meron lang tayong dalawang data points. So yung interpolating polynomial that I am expecting out of these 2 data points will just be at most a linear function. All right? Kasi 2 data points, so we expect a linear function. So I will have a P1. Tapos, again, siya pa rin ay sum I going from 1 to 2 ng function value times the Lagrange basis polynomial. So if I'll write this down, first function value times Lagrange polynomial, Lagrange basis polynomial, which would be 1 degree less than the number of points. So this would be x minus 2 all over 1 minus 2 plus second function value times x minus 1 over 2 minus 1. Okay? And obviously, these two terms are both linear in x. So ibig sabihin, pag sinimplify ko to, linear function lang yung makukuha ko. And I think here what we get is 3x minus 2. Tama ba? 1, 1, 2. Yes, I think that's it. The idea here is we have a 1, 1, point at 1, 1. We have a point at 2, 4. Okay. Kahit sasabihin natin na, okay, alam ko magpapass dyan yung parabola x squared. However, interpolating polynomials is always are always 1 degree less than the number of points used. So I will not try to fit a quadratic function into these 2 points, but instead I will connect them using a linear function, and that is just a line. So I'm just considering the line passing through 1, 1, and 2, 4. Okay. So if you decrease the number of points, then you might get a different interpolating polynomial because we need to satisfy a certain degree requirement. Okay, so we have an upper bound for the degree of the interpolating polynomial. Okay, so I hope these 3 examples give you more insight on how to do or how to find the interpolating polynomial, at least manually, because I always find it easier to write a code for something if at least I have tried writing it on paper. Para alam ko na kagad ano yung nangyayari dun sa process. Okay, let me see. Yeah, that's right. That's 3x minus 2. Okay. So questions before I proceed to the next part of the discussion? So pag sa problem set pa, pinagmano-mano kayo ng Lagrange interpolating polynomial, you can do it?
Kaya po, sir.
Okay, thank you, hopefully. So now let's go back to the epidemic model. Remember last time we were talking about this epidemic model. Actually, the data is here in table. And then sa introduction yung table. So yeah, meron tayong 2, 4, 5 data points here. And again, we introduced the problem of finding the weekly data. Okay, kasi sabi natin, usually in real world, ang makukuha lang natin ay discrete set of data. But sometimes we want to make sense of the data by doing some analytic, some analysis to it, right? But the analysis that we knew from our calculus courses require a continuous function. And luckily now we have a way on how to model this using a polynomial. And that can be easily fed into those analytic tools that we learned in our pre-calculus classes, or sorry, our calculus classes. Ang problema ko lang dito ay malalaking numbers. So in order to get the Lagrange interpolating polynomial or the algebraic interpolating polynomial, I might resort to use calculators or a spreadsheet, or better yet, use a high-level programming language such as MATLAB. So today I'll share with you how to do this in MATLAB. Though I mentioned na hindi required na MATLAB yung gamitin sa programming, pero sa klase ang gagamitin ko ay MATLAB. It's just because MATLAB talaga yung ginagamit ko sa aking research. And then also, you have free access to MATLAB. You can get a licensed version of MATLAB. Pero I don't think it's a big issue because if you understand the process, you know the algorithm, then it is just a matter of semantics or translating that algorithm into the syntax of your programming language of choice. Okay. So I hope you see my MATLAB screen. Hopefully, malaki na yung font. Makita nyo na siya. So let's see, how can I implement the Lagrange interpolating form, the Lagrange formula for the interpolating polynomial using MATLAB. Okay. Now I'll walk you through at least the syntax and the various parts of this program. Makita nyo, maiksi lang yung program. So yeah, dalawang for loops lang yung meron. But first in MATLAB, MATLAB has a nice way of handling symbolic variables. So pwede kayong mag-compute as if you are doing it by hand. Kasi pwede tayong mag-declare ng symbolic variables in MATLAB. When you download MATLAB, make sure you download the symbolic toolbox. So ang UP subscription naman, it covers all of the toolboxes. So pwede nyo i-download lahat ng feeling nyo gagamitin yung toolboxes kasi bayad na yun ng university. So, but make sure at least you have the symbolic toolbox. So to declare a certain variable to be a symbolic one, kailangan ko yung syntax na SYMS, SYMS. So this will tell MATLAB, wag mong pakalaman yan, hindi yan magre-represent ng isang number. So it is a symbolic character. Okay? So kasi t yung gagamitin kong coefficient para dun sa time variable. Okay? And then line number 3, nilagay ko lang yung mga abscisas, yung mga t value dun sa table. So t equals 0 means day 0 after the epidemic broke. T equals 10, that's 10 days after the epidemic broke, and so on. And then D is the number of deaths according to the data. So kinopya ko lang yan sa table. So one thing about MATLAB, MATLAB stands for Matrix Laboratory. So yung intrinsic nature or design in MATLAB is for matrices and arrays. So usually, iti-treat niya yung mga variables as an array. Pwede rin namang scalar, pero sa isip ni MATLAB, yung scalar mo ay 1 by 1 matrix or 1 by 1 array lang. Okay? So that's what this vector D is for, para i-store yung data. Okay? In MATLAB, yung vectors or matrices laging enclosed by square brackets. And then there's a semicolon here para wag i-output ni MATLAB yung line na yon o yung result ng line na yon. Okay, so para lang hindi ko makikita yung t, hindi kakalat dun sa command window ko. Okay. All right, and then value assignment, equal sign lang. Hindi kailangan ng colon equals, just as like in other programming languages. Okay. Now remember, dun sa Lagrange interpolating polynomial, meron tayong summation. And I guess you already learned that usually for programming languages, kailangan mo lagi ng starting value kung mag-start ka man ng summation. So here, I will be reserving the variable p for my Lagrange interpolating polynomial. And since p is to be computed as a summation, I'll need to assign the starting value. I'll initiate it to the value 0. Okay? And then, kailangan ko ng for loop para dun sa summation. Okay? So here's the summation for k. Gagawin ko siya from 1 until yung size ng set of abscisas. So yung size t2, kino-compute nyo lamang gaano kalaki yung second dimension ni vector o ni matrix T. Remember, MATLAB treats all variables as matrices or arrays. So kung bibilangin niyo to, kapag ka walang pag spaces lang yung nagse-separate dun sa numbers, ibig sabihin iti-treat to ni MATLAB as a single row. Kung gusto niyo ng columns, kailangan niyo lagyan ng semicolon. So pag may semicolon, ibig sabihin column vector siya na 0, then next row would be 10, then 25, 50, and so on. But I will keep it as a row vector. So ibig sabihin, iti-treat to ni MATLAB as a matrix of one row by 1, 2, 3, 4, 5. By 5 columns. So it's a 1 by 5 matrix. So yung size, kino-compute niya yung dimension ng matrix T. So si matrix T, so kung size of T lang yung ipapakompute ko kay MATLAB, ang ibibigay niya sa akin ay 1, 5. Number of rows, number of columns. However, I specifically told MATLAB to compute the size of the second dimension. So size of the second dimension, so si T ay 1 by 5, second dimension is 5. So the summation for the for loop for K goes from 1 until 5, representing each of the abscisses. Okay? Now, kung makikita nyo dito sa line 16, dito ko nako-compute bawat term or paano ko nabubuo yung summation for K. Kinukuha ko yung previous value ni P, tapos dinadagdag ko lang yung function value at the kth abscissa. So ito yung D of K. So ito yung number of deaths at the kth day times LK. Yung LK, siya yung Lagrange basis polynomial L sub K. Okay? And remember how we compute the Lagrange basis polynomials. The Lagrange basis polynomials is a product, right? So kaya dito, i-initiate ko ng LK ay equal K1 kasi mag-multiply ako na mag-multiply. So hindi ko pwedeng start sa 0 kasi pag ginawa kong LK equals 0, ang susunod kong product would be 0 times whatever the corresponding term is, mag-0 lang siya palagi. So the right initial value for LK is 1. I do the product inside a for loop indexed by I, going from 1 until the size of the second dimension of the array T. Kaya lang, remember, meron tayong exemption. Hindi pwedeng yung I mag-equal kay K. Kasi yung denominator, remember, the denominator is x sub K minus x sub I. So kung papayag ako ng I ay pwedeng maging equal kay K, magrereklamo si MATLAB because I'll be dividing by 0. Okay? So to tell MATLAB, do not include the factor when I is equal to K. So gagawin ko lang yung production o yung pagtitake ng product if I is not equal to K. And then the value of LK will be updated as the previous product times the current factor. So this is the variable T. Dun sa formula natin X yan, pero just to symbolize the time variable, I'm going to use T here. T minus the abscissa all over T sub K, the abscissa at the iteration K, minus the current abscissa. And that would be my LK. Tapos yun yung i-multiply ko sa function values. Okay? And once I get out of this double for loop, I'm going to get the Lagrange interpolating polynomial P. Okay? So, yung Lagrange interpolating polynomial P, pwede ko siyang ipa-output kagad kay MATLAB. So, siguro, i-comment ko lang to. Kapag ka naka-comment siya, ibig sabihin hindi siya irarun ni MATLAB. So once I have written this code, I'm sure I'm going to get P out of lines 1 until 17. I'll just click run here. If you see on the top of my editor, there is a play button here. Yung may run sa ilalim. I'll just click that. And makikita ko na nag-run na yung program ko. Right? An indication that your program already run, lalabas yung title ng script. So yun yung title ko, EX 2021-0921.m. Tapos dito sa right panel, you'll see the workspace. Nakikita nyo na ba yung workspace? So yung workspace magkakalaman na siya, nandito lahat ng variables na na-compute niya. Kita niyo, nandito si D, nandito si I, nandito si K, si LK, si P, si T, at saka si capital T. Ito yung mga variables that were assigned with certain values inside your program. But you notice that in the command window, there is no output. Wala kang makikitang output kasi lahat sila nilagyan ko ng semicolon sa dulo. If you want to see some of these numbers, just suppress the semicolon. Tanggalin yung semicolon, and sa line 6, tanggalin ko yung semicolon. So expect ko yung P equals 0, i-output yan ni MATLAB. So if I run my program again, I'll get the file name of my script, but also P equals 0. Kasi hindi ko sinopress yung display ng P equals 0. But of course, if you're running on long code, you might want to suppress those output na hindi mo naman kailangan makita, especially the results of intermediate calculations. Okay? Now, what if nagbago yung isip mo? Gusto mo palang makita ano yung value ni P, pero hindi ko siya pina-display. So you don't need to run the program again. You can just go to the command window and type P. Right? Si P ay na-compute niya na after the for loop. So pag tinype ko si P sa command window dun sa ilalim, and then I hit enter, I'll get this long expression over here. That is actually the Lagrange interpolating polynomial in symbolic form. You see the presence of the variable t. That's my time variable. MATLAB knew to treat these treat t as a variable. So hindi niya yung pinalitan by any value sa makita niya. Okay. Another way to display the value of a certain variable, pwedeng sulat nyo ay disp and then the variable to be displayed. So ipapakita niya rin yun. Either you put it on the command window or you put it as part of your working file. Okay? Kaya lang mahirap kopyahin to, no? So kung napakahaba ng expression, di pa siya naka-fraction form. One way to output the any symbolic function in MATLAB is to use the command pretty. So pretty of P, ibig sabihin ilalabas niya si P in a prettier way. So ganun yung pagkakapangalan ng mga commands kay MATLAB. Medyo intuitive siya. Sometimes it's witty. So either i-type niyo yung pretty P dun sa command window kasi na-compute na natin si P, or isama mo na lang siya sa code mo para pag ni-rerun mo siya, okay, makita mo yung prettier version ng polynomial P. So ibig sabihin ito siya. So ito yung first term minus the second term minus the third term plus the fourth term. But of course, this is not still so very good for us. Marami ka pa rin kokopyahin. You can also ask MATLAB to simplify the expression. So, meron dito I can look at line 20. So line 20, meron akong P equals simplify P. So, ibig sabihin, itatry ni MATLAB na i-simplify yung polynomial P. And since I am assigning the simplified version of P to the variable P, ma-overwrite niya na yung previous value ni P. Yung nakita natin na mahabang fraction kanina dito sa command window. So I can again just rerun the program with line 20 uncommented. So wala siyang wala siyang percent symbol sa umpisa. Pag may percent symbol sa umpisa, ibig sabihin i-ignore lang ni MATLAB yun, din niya i-run yung command na yon. So pag nirerun ko yung program, mapapasama na to, i-compute niya na si P to be the simplified version of the previous value of P. Pwede rin namang i-type nyo lang yung simplify P sa command window. Or you can simply highlight this portion, right-click to it, tapos merong evaluate selection. So ang gagawin nito, i-evaluate lang ni MATLAB yung highlighted portion ng code. But make sure na na-compute na ni MATLAB before lahat ng kailangan para sa line na to. And you can verify that you have those variables available if you look at the workspace. Makikita nyo sa workspace dun sa kanan nandun lahat ng available variables na pwede nyong gamitin. So you can click evaluate selection para i-run lang yung line 20, or you highlight line 20 and then press F9. So parehas lang naman yun. So, okay, unfortunately here I also highlighted the colon. Kaya hindi naka-output sa command window yung simplified version ni P. So makikita nyo nakasuppress. Pero the assignment has been done. Kinompute na ni MATLAB si simplify P, tapos inassign niya na yung simplified version to the variable P. So if I really want to see the variable P, type ko lang yung P sa command window, press enter, you'll get the simplified version. Okay? So ibig sabihin na perform niyo na lahat ng simplification na pwedeng gawin. Or if you're not comfortable with this form, pwede nyong ipakompute yung pretty P. Command window ko na lang siya gagawin. Type pretty P sa command window. Hit enter. So you see, mas maganda ba yung output? Let me see. Okay. So yung output niya ay T times negative 150,469 T cubed plus this guy times T squared. Just be careful. Yung exponent ay nandun sa previous line and so on. And then there is, I think, a pair of parentheses here, prompting us that this is an entire numerator and the denominator is 6.75 million. Okay. Now, of course, minsan hindi nagme-make sense kung titingnan lang natin yung function. So it's sometimes better to visualize the function by looking at its graph. And that's what lines 24 and 25 are for. Uncomment ko lang sila. I can press the uncomment button here at the editor tab or just press Control T. Or burahin ko lang yung percent sign dun sa simula ng lines 24 and 25. That will also be fine. So what is line 24? So line 24, if you press, if you have figure, mag-aalat lang siya ng isang figure window para hindi tatabunan yung previous figures. So it's a nice practice to always put a figure before kayo magpa-plot or magpa-produce ng kahit anong figure kay MATLAB. Line 25, it will plot the symbolic function. So the command for plotting a symbolic function is fplot, and then parentheses. The arguments are as follows. Una, ano yung symbolic variable na gusto nyong ipa-plot? So here, we have computed P. Gusto ko ipa-plot yung symbolic polynomial P, which, remember, is our Lagrange interpolating polynomial. The second argument is a vector consisting of the minimum value for x and the maximum value for x. Okay? So since our data set or our t-values start from 0 until 100, so ginawa ko na lang x limits on the x-axis yung 0 hanggang 100. So again, since maiksi lang naman yung program, pwede kong iparun uli kay MATLAB lahat by pressing F9 or the run button. Okay. Pag ginawa ko yan, lalabas na ito at makukuha ko in a separate window yung graph nung okay, so hindi nyo pala makikita yung graph kasi gumawa siya ng bagong window. Tapos naka-share window lang ako. Hold on. Let me share my entire screen instead para hindi ko na kailangan siyang ulit-ulitin. So, okay. There we go. I-maximize ko lang yung MATLAB ulit. Okay, here we go. So, nirun ko uli yung code with lines 24 and 25 uncommented out. And then I can, pag nirun ko siya, makukuha ko tong figure na to. Okay? Which basically gives me the graph of the interpolating polynomial P over the interval 0 to 100. Okay? Questions so far? I hope nakikita niyo yung intuitive language ni MATLAB. Okay. Of course, you can explore MATLAB later on your own, or if you don't, if you think it would be harder for you to use MATLAB, you can use any other programming language. But I guess MATLAB is easy. So kung pwede naman or wala pa kayo naiisip na programming language, you can try MATLAB. Okay. Now, the problem in the introduction is a researcher wants to analyze weekly data. So, kailangan nating ibigay sa kanya yung weekly data. Hindi ko pala siya nilagay dito. Pero for instance, I want to get a discrete set of data. Say, gusto kong malaman yung weekly values. So, pwede akong mag-create ng isang vector of t values kung saan ko gustong i-evaluate yung polynomial. Halimbawa, gawin kong t weekly or tw. Gagawa ko ng vector. This will be the vector starting from 0 until 100 of increment 7. Kasi gusto ko yung weekly data. So I will start at 0 and then I'll increment the time step by 7 days hanggang makarating ako sa 100. Okay? So ito yung syntax para bumuo ng vector starting from the first number, ending at or not exceeding the third number with increment the middle number. Hopefully tama yung syntax ko. So let's see. I'll enter that 7. Mukhang mali yung syntax ko. Try ko nga 0, 100, 7. Tama ba? Hindi yun yung gusto kong syntax. So, tama yata yung kanina. Let's see. TW equals 7, 100. Okay, there you go. Ano na bago? Okay. So, ang TW ko ay starting from 0, increment 7 until before it reach 100. Okay. So, you will see here TW is 0, 7, 14, 21, until 98. Kasi pag nag-add ka pa ng 7 sa 98, that will give you 105, which is beyond the upper limit for the TW values that I want. Kasi ito yung weekly data. Okay? So, nakuha ko na yung X values, yung mga bagong T values, kung saan gusto kong evaluate yung interpolating polynomial. So, ngayon, it's up to us to plug these values into our interpolating polynomial. And for MATLAB, the substitution command is subs, S-U-B-S, and then laging ang argument ay enclosed in parentheses. You can either put this into your main code or kung naisipan nyo lang siyang gawin after na-run nyo na yung buong code, sa command window nyo na lang siya gawin na para nagka-calculator na lang kayo. So you type subs. The first argument is your symbolic function. So ang symbolic function natin ay p. Okay. Tapos ang variable would be the second argument. Ano yung gusto nating palitan na variable? Saan natin gusto mag-substitute? Since the polynomial p has the symbolic t in it, and you want to replace t by the values in the vector tw, lalagay ko lang dito yung variable t. And then the third argument for subs ay saan mga values mo gustong i-substitute o ano yung mga values na gusto mong i-substitute kay t. Well, we already computed that and we stored those values in the vector tw. So basically this command tells MATLAB to substitute in p all the values of tw in exchange for the symbolic variable t. Tapos siguro gusto kong i-store yung result into say a vector dw. So or weekly number of deaths. So dw equals subs. So kukomputin niya yung substitution. Tapos yung sagot, i-assign niya or i-store niya sa variable dw. And let's see if this will work. Okay. So dahil hindi ko nilagyan ng colon, in-output ni MATLAB, dw. Okay. So ito dapat yung command ko, dw equals subs. Okay. So dahil hindi ko siya nilagyan ng colon, in-output ni MATLAB yung dw. Okay. So kaya lang naka-fraction siya kasi symbolic variable yung dw. So pinlog in talaga ni MATLAB para makita ko yung exact fractions dun sa final answer. But if you want to get decimal representation for these numbers, you can use either the double command, so double DW, tapos i-assign ko rin siya halimbawa kay DW. Papalitan ko si DW by the double precision representation of the values in DW. Okay. So ibig sabihin lang, i-evaluate ni MATLAB itong fraction na to using double precision. So ibibigay niya sa atin in decimal. So let's see, hindi ko siya lalagyan ng semicolon kasi gusto kong makita kung ano yung result. And true enough, ito yung nakita natin. Kaya lang be careful sa output ni MATLAB. Usually ilalagay niya yung values. Pero sa unahan, baka may makita kayong multiplier. So for instance here, DW is equal to 1 times 10 to the 4th times yung vector na to. Yun yung drawback kay MATLAB. So huwag kayong maging kampante sa pagkopya ng answer kapag mahaba yung vector kasi baka merong multiplier din sa umpisa. Another way to see the results rather than the command window is through the workspace. Punta kayo sa workspace, dun sa kanan na panel. Makikita nyo si DW rito along with all the variables that we have computed. You can double-click on the variable name. So ito, i-double-click ko si DW sa workspace. Mag-open ng bagong tab si MATLAB aside from my beside my editor. Tapos makikita nyo na nakaparang Excel yung results. So here I see that D equal so this is t equals 0, this is for t equals 7, this is for t equals 14, and so on. So makikita nyo yung values. But unfortunately, the second value here corresponding to t equals 2 doesn't make any sense kasi meron daw negative 209.68 deaths on day 7, which doesn't make any sense. So yeah, that's the cost of modeling. Merong mga extraneous values tayong makukuha. That's probably one disadvantage of using polynomial approximation because kung polynomials, posible magkaroon ka ng zeros. So kahit hindi feasible yung negative values, mapapasama siya dun sa ating model. Okay? So yeah, you can do it in the workspace. You can get the values here. You can copy paste into Excel and so on. Okay? Questions so far? Okay. Kung wala, let me use the last 2 minutes showing you some other features. Okay? Now, we promised that polynomials are advantageous because their derivatives are also polynomials and they are easily easily computed via computers. So MATLAB can also compute the derivative for certain symbolic functions. Dahil polynomial lang naman si P, kayang-kaya ni MATLAB i-compute yung derivative niya. And you can just ask MATLAB to do so by using the command diff, D-I-F-F, and then inside put your polynomial, the function name. So the function name is P. So ito yung derivative niya. Okay. Or if you want a prettier output, so use pretty, and then inside of it, diff P. Okay. So kukunin niyo muna yung derivative ni P, tapos i-display niya ito in a pretty format. So yun na pala yung pinaka-pretty daw niya. Pero siguro ipa-simplify din natin. So simplify diff P. So kaya posibleng mag-call kayo ng several functions on a single line. So here I ask MATLAB to find the derivative of P first, simplify it, and then display it in a pretty fashion. So ito na yung derivative ni P. Okay. Which as expected is degree 3 kasi yung polynomial natin ay degree 4. Okay? But again, instead of just looking at the function, pwedeng pa-compute natin yung, ipa-drawing natin yung graph ng function o ng derivative ni P. So again, I can run lines 27 and 28 and comment ko lang sila. And then I'll hit F9 para ma-run yung selection ko, yung highlighted portion. And a new window will pop up with the graph of the derivative. Okay? So ito yung graph no derivative ni P. Okay? Pero saan nga ba natin nagagamit yung derivative function. So what if we want to get the maximum number of deaths over the interval 0 to 100? Remember, this is the graph of our epidemic. This is our epidemic curve, right? And note that it peaks here between 70 and 80. Now, to make sure when is the maximum death toll occurred, so pwede kong gamitin yung tools for Math36. Remember, from Math36, kailangan ko lang kunin yung zeros nung first derivative. Sila yung mga critical numbers. So luckily, MATLAB knows the polynomial p. It can compute the derivative, okay? And a bonus for us, kayang mag-compute ni MATLAB ng roots ng isang polynomial. Okay? So medyo two steps nga lang yung procedure. First, kaya lang ni MATLAB i-compute siya using the command roots. So pwede nyo i-search sa help o dun sa documentation dito sa upper right-hand corner, yung roots. Ilalabas niya yung suggested readings. So you can click on, say, roots. Kasi gusto kong i-compute yung polynomial roots. Dadalhin niya kayo sa isang documentation page para dun sa function na pinili nyo. Okay? At madali lang pala yung syntax ng roots. Para makuha yung roots ng isang polynomial p, kailangan lamang ay, oops, napalaki masyado. Ang syntax lang ay roots p. Okay? Pero ano yung requirement? Roots p, dapat si p ay vector. So the input p is a vector containing the coefficients of the polynomial. So instead of halimbawa hanapin niyo yung roots ni 3x squared plus 2x minus 2, dapat daw ang input dun sa roots function ay 3 to negative 2, which are the coefficients of decreasing powers of your polynomial. Okay? So yun yung caveat dito sa paggamit ng roots. Pero luckily, meron ding built-in function si MATLAB para i-harvest ano yung coefficients ng isang polynomial. So ang syntax ay seems to poly. Double check ko lang. Hindi ko kasi siya laging ginagamit. May kodigo ako dito. Yeah. Seem to poly lang pala. Seem to poly. So, ang input niya ay isang symbolic function. In our case, we want to get the zeros of the derivative, right? So, ipapasok ko kay seem to poly yung derivative ni p para ma-harvest ano yung coefficients nung derivative ni p. And then, i-store ko siya sa variable coef. So, coef equals seem to poly diff p will give us a vector comprising of the coefficients of the derivative of p. Hit enter, like this. So ito yung approximate values in decimal form ng coefficients ng derivative ni p. Okay? And then remember, anong gusto natin makita? Gusto natin makuha yung critical numbers. And the critical numbers are the roots of the derivative of p. Okay? We already know the coefficients of the derivative of p. So, pwede kong gawin, computein yung zeros, which are our critical numbers. Store ko siya sa variable cn. Tapos ang syntax ay roots. Tapos ang input ay yung coefficients. There we go. These are the critical numbers. So, nagsi-zero yung first derivative sa 73.71, sa negative 28, at saka sa 5. So kung babalikan natin yung graph ng derivative, so perhaps, yeah. So ito yung 0. So true enough, yeah, nagsi-zero siya somewhere between 70 and 80, which we expected kasi nasilip natin yung graph ni P. Nagpipeak talaga siya sa P equals somewhere between 70 and 80. Yung isa pa niyang root ay nasa 5. So yeah, 5 point something. So nandito siya sa area na yon. So it seems that the calculations are pretty accurate. Now, remember, para mahanap yung maximum value, kailangan nating i-plug in lamang itong 73.7115 to see the maximum number of deaths. Okay? And again, remember, to do the substitution or the plugging in of a number, kailangan natin yung subs command. Kung gusto kong mahanap yung maximum number of deaths, isa-substitute ko yung critical number, which I know to give me the maximum. to the polynomial t, I'll replace the variable t, and I will use 73.7115. You can just type in 73.7115 here, or you can call Cn, tapos kunin niyo yung first entry ni Cn. Para mahanap yung first entry ni Cn, sabihin niyo lang Cn of 1. I-output ni MATLAB yung first component or first entry ni Cn. Don't forget the closing parenthesis para kay subs. And here, you will get this long fraction. Okay, meron niyang over sa dulo. Nasaan yung over sa dulo? Okay. Ito. So it's a big fraction. So if you want the exact value, MATLAB can give that to you. Pero it doesn't make sense kung fraction siya. Madaling i-interpret kung siya ay decimal digit. So you can use double. And unfortunately, hindi ko na-save into a variable yung result ng computation natin kanina. Yung substitution, hindi ko siya na-store sa isang variable. Pero ang kagandahan tayo ng MATLAB, ini-store niya yung previous answer to the variable ans. So kung siya yung immediate answer or immediate previous answer, gusto ko siyang gamitan into another computation, pwede kong gamitan yung ans na lamang. So ipa-plug in ni MATLAB dun sa function double, yung previous answer na nakuha ko. And that would be 3.2131 times 10 to the 4th power. So basically, that's going to be 32,131 point something. So kung ayaw nyo na yan, pwedeng VPA. Check ko nga yung VPA. Parang pwede yung VPA. Okay. The VPA command will give you another form. Hindi niya gagawing scientific notation. Ilalabas niyo yung decimal form. So the command is VPN sa makuha niyo ito. So let's see if that makes sense. Let's go back to the graph of P. So we already resolved na yung maximum nangyayari between 70 and 80, and precise calculation showed nangyayari siya sa 73 point, what was that? 73.7115. Tapos ang value niya ay about 32,000, which is 3 times 10 to the 4th plus some change. Okay? So as I expected, hindi ko natapos, but perhaps I'll stop here and answer a few questions if you have some. Let me share my screen. Or medyo overload ba? Medyo napagod ako sa discussion na yan. Any questions? Tapos overtime pa ako, tapos ang dami pa natin ginawa. So perhaps that's information overload, but the silver lining of this remote setup is if you find the discussion too heavy, you can go back again to the recording later and pause it kung medyo mabilis, or kung meron kayong hindi na-catch na concept, pwede niyong balikan yung recording. Okay? So any questions? We still have a good portion of Module 2 unfinished. Perhaps I'll ask your laboratory instructors to discuss portions of it on the lab class on Monday. At dahil may discuss pa kayo sa Monday, siguro ay i-extend ko yung deadline nung Lab Exer 1.1. Perhaps I can make it to Wednesday. Okay lang ba yun? So I'll just announce it in Canvas na extended yung deadline ng homework ng Lab Exer 1.1, kasi sa Monday perhaps you'll spend 1 hour to discuss the remainder of the module. Tapos okay na ba yung Wednesday? Or gusto niyo gawing Thursday?
Okay naman po yan, sir.
Wow, kakaiba. Talagang shy pa kayo, no? Hindi pa kayo marunong mang-abuso or something. Okay, for now, let's do it on, let's set it to a Wednesday, okay? So, dahil 3 hours naman yung lab nyo, so pwedeng discussion yung first hour. And then dahil designed naman yung exer to be good for 1.5, so you can still finish it then. But to give you time to review your answer, or yeah, if you want to finalize it a little bit more or fine-tune it. So yeah, let's do it. Let's move the deadline to Wednesday, okay? So I guess that's it for me today. Sorry, I overtime na ako. So let's end it here. I hope you enjoyed the rest of the day, the rest of the week. and also the weekend as well. And let's see each other again on Tuesday. Okay. Bye, guys.
Bye po, sir. Thank you po.
Thank you po, sir.
Thank you,
Thank you,
sir.
sir.